Okay, Year 10, starting the next part of this chapter, which is solving simultaneous equations. Now, essentially, there are two ways to solve simultaneous equations. There is the graphical method, and then there is the algebraic method. And we're going to start off with the graphical method. It's not a very good method because you have to draw, as you can see here, accurate graphs, and it's time-consuming. I'm only really going to want you to do these last ones, E, G, H, and I. And I'm going to do, sorry, not E, F. I'm going to do F, and then I'll do H. So F, and I've got two equations here. I've got y equals 2x minus 6, and I've got y equals, oh no I don't, it's not written as y equals, so it's 3x minus y equals 7. Now, if I'm going to draw these graphs, I have to plot points. So the first thing I'm going to do here is I'm going to create a little table. And I know that they do it the other way around in the book, but I'm going to do mine vertically. And I pick 3 values for x, and I usually pick a negative, 0, always pick 0 and 1. Now if I put negative 1 in here, I'm going to get 2 times negative 1, which is negative 2, minus 6, I'm going to get negative 8. If I put 0 in there, I'm going to get 2 times 0, minus 6, I'm going to get negative 6. And 2 times 1 is 2, minus 6 is negative 4. And they're my 3 points. Why do I choose 3? In case I make a mistake, and they won't form a straight line. Now, the first thing I've got to do over here is I've got to rewrite this. So I'm going to take the y over the other side, and I'm going to bring the 7 over. So I'm going to get y equals 3x minus 7. All right, so if I added the y over and subtracted the 7. Now I go x and y. I choose my 3 points. Again, I'm going with negative 1, 0, and 1. And sometimes you'll jag the answer in your actual little table of values. So if I put negative 1 in here, I get 3 times negative 1, negative 3, minus 7 is negative 10. 3 times 0, minus 7, negative 7. And 3 times 1 is 3, minus 7 is negative 4. And there are my 3 coordinates. Now if I just did a rough graph over here. So I got myself a number plane. And I plotted these points. And it's just going to be rough because I don't have a ruler. So I've got negative 1 and negative 8. So I have to go down here 8. 1, 2, 3, 4, 5, 6, 7, 8. So about there. I get 0 and negative 6. 1, 2, 3, 4, 5, 6. There. And I get 1 and negative 4, which is about there. So I get this line going, come on, where is it? Oh, and it was through. It just came up late, that bugger. There. Now that's not very accurate, but it'll have to do. Now I'm going to plot the other 3 points. I'm going to do them in the reverse colours. I'm going to do them in blue and then do a red line. And negative 1 and 10. Well, that's nearly off the scale. There's 8, 9, 10. So that's there. Negative 1, 0 and negative 7. Well, that's there. And negative 1 and 4. 1 and negative 4, look at that. I jagged it. I jagged the solution in my little table, but there. And as you can see, you have to draw an accurate graph to get the point of intersection, which is 1 and -4. Now the next one I'm not going to do using, oh no, I will. We'll see how we go. So let's have a look. I'm going to do H, and I'm going to leave you to do G and I. So H, and I've got y equals x, and I've got y equals x plus 4. So x, y, and again, -1, 0, 1, -1, 0, 1. And I tend to go negative first because I'm going to be doing that. That makes it easier because I'm going from left to right. So all I've got to do is substitute in there. Oh, so y will equal -1, 0, and 1. Well, they're pretty easy coordinates. And over here, I'll put -1 in there. -1 plus 4, 3. 0 plus 4, 4. 1 plus 4, 5. They're my coordinates. And I'm going to use this table again, this one over here, because we've already got it, and -1 and 1. Well, I'll draw this in the blue. There's -1 and 1, 0 and 0, and 1 and 1. There are those 3 points. Let's draw a line through those. Oh, that'll have to do. I'm not going back and fixing that up. Okay, I will. Here we go. There. Righto. So there's the first line. Now, the second one, -1 and 3. So I have to go along here, go up through 1, 2, 3. There's going to be a 4 and there's going to be a 5. And I'm going to plot these points in red. So -1 and 3, that's there. 0 and 4, that's there. And 1 and 5, that's there. And I'm going to draw a blue line through these ones. Okay. Come on, where are you? That'll loop. Now, I could keep drawing those lines for as long as I could, but they're not going to intersect. Y equals x plus 4 and y equals x are not going to intersect. Why? Because they're parallel. Now, we should have known that because the gradient here is 1 and the gradient here is 1. The gradients are equal. So there is no point of intersection for H. The lines are parallel. I'll let you do G and I because I really just want to concentrate on 3 now. So here's the big thing. This graph represents the cost after kilometres of a new car from 2 car rental companies, Paul's Motors and Joe's Car. So Paul's in red, Joe's in blue. Determine the initial rental cost from each company. You'll notice here too, they do this little thing, which is important to understand. They don't start from 0. They put that little indicator there to say, we could go another 60 down, but that would make the graph too big. So we go on 0, skip a few, 60, and we're starting at 60. So, okay, Paul, well, let's start with Joe. So here's, and I'm going to do them here. Here's A, number 1. Well, Joe's, its initial starter, $60. So if you rent a car from Joe, you pay $60 before you even go anywhere. But Paul, he's even more. He's halfway between 140 and 160, so I'm going that his startup cost is 150. Find the cost per kilometre when renting. Well, the cost per kilometre is just going to be the gradient, right? So how much do I pay per kilometre? Well, 60, and I'm going to go to here, because there's a dot there and I can see it. So for 900 Ks, it goes from 60 to 240. So 240, and this is for Joe's, 240 minus 60 means it's 180 to go, what's that, 900 kilometres. So 900 divided by 180, and I'll have to use my calculator here, 900 divided by 180. Is that going to be, so that means 5 kilometres for every $1. Find the cost per kilometre. Oh, so I've got to do the other way around. So 180 divided by 900. 20 cents. 20 cents. So I should have done that the other way around because I've got the cost. So 180 divided by 900 equals 0.2, so 20 cents. Paul, on the other hand, if I do my little triangle from here to here, for the 900 it goes from 150 to 240. So 240 minus 150. And 240 minus 150 is at 90. Therefore, 90 divided by 180 equals, not 180, 900, thank you. Well, that's going to be a tenth, it's going to be 10 cents. 90 divided by 900, 10 cents. All right, I'm going to let you do the others. The main thing I want you to be able to do, because these are not too hard, find the linear equation. Well, you've got the y-intercept and you've got the gradients. That's what they're getting you to get here. So this is a gradient. Well, I will do it. So there's a gradient. So if I'm going to find the linear equations here, so I'll just rub this out here. Find the linear equations. I'm just going to do Paul. So Paul, you can do the other one. So it's 1, 2, 3. You can do Joe. So Paul, the y-intercept is 150 and the gradient is 0.1. So therefore, the cost equals 0.1 times kilometres. Notice that I've changed my x and y. Remember I'd write y equals mx plus c. Well, my y is c, my x is k, and my y-intercept is 150. You could write that a different way. I'm just going to rub this other stuff out of here because it's a little bit confusing. You could write it a different way. You could write it the cost. And this is how it's 150, take it out the door, plus 10 cents every kilometre. All right, you work out Joe's. Okay, if you had to travel, which one? Okay. I want to talk about this point where they meet, because that's the key. Now, in some cases, they call it the break-even point. Here it would be say, well, it doesn't matter which one you use, you're getting the same cost. And that's that point here. So, if you're travelling 900 kilometres, it doesn't matter who you use, Joe or Paul, it's going to cost you $240. All right? All right. You can answer the other questions about those, but solving equations graphically, realising if they're parallel, there will be no solution. Good luck with those.